Let's learn the other property, electronegativity. So first let me define what is electronegativity. The electronegativity is defined as the relative tendency of atom in a molecule to attract the shared pair of electron towards itself. So I have written A and B, these are the two atoms. So in the middle, one covalent bond I have written. That covalent bond shows both the atom equally shares its electron. When I consider A, these two atoms is common for A, and when we consider B, this is common for B. So, but actually these two electrons are shared by between A and B. But the electronegativity means the relative tendency of atom in a molecule to attract both the shared pair of electron towards itself. If A is highly electronegativity, then it will pull both the electron towards itself and get converted into A carry partially negative, because A is pulling the electron. So when the electron migrate towards A, it carry negative, and it goes towards B slightly partially positive, because both the electrons are shifted towards the A. So it carry partially negative, this is partially positive. So this is what called to be electronegativity. So you all know that in the periodic table, when we move from left to right, the electronegativity increases. The En is electronegativity, it increases. Likewise, when you move top to down, the electronegativity will decrease. This is what the general trend which we studied in the periodic table. So this electronegativity will also be related to atomic radius. So here the electronegativity will be inversely proportional to the atomic radius, because you all know when you move from left to right in a periodic table, the atomic radius decreases. As the atomic radius decreases, as the atomic radius decreases, the electronegativity increases. So smaller atom will have greater tendency to pull the shared pair of electron towards itself. That's the meaning. But in this chapter, we are going to see what is the electronegativity variation in group elements. Like I'm going to write the 13 group element, that is boron, aluminium, gallium, indium and thallium. When we compare the electronegativity, the boron electronegativity top to down, actually it should decreases. The electronegativity value of boron is somewhat 2.0. Likewise, the electronegativity of aluminium somewhat 1.61, like that, 2.04. So when you compare this boron and aluminium, the electronegativity value decreases. As we studied in the periodic table, top to down it should decrease. So likewise, boron to aluminium, it decreases. But when we compare aluminium to gallium, the gallium value will be 1.8, like that. So it shows the electronegativity value increases. From aluminium to gallium, actually it should decrease, but here it increases. And here too there will be a marginal difference from aluminium to gallium, which we studied like ionization energy in the previous session. Same way, only to boron to aluminium there is a decrease, the remaining else there will be a marginal change. And aluminium to gallium there is a slight increase. But the group 14 also follow the same trend. From the first element, carbon to silicon, there will be a decrease in the electronegativity, but the remaining else marginal. But 15 to 18 it follows the normal, and there will not be much change. So it all related. This electronegativity can also be related to the atomic radius.